Hey, it's Mr. Barr, and today we're going to be graphing linear inequalities. If you can graph lines, you can do inequalities. And there's a ground squirrel. Our goal is I can create and use linear inequalities and graphs to solve or to model real life situations. Life is rarely equal. I want to be able to use the concept of greater than and less than to solve problems. I have $20 to spend, but I do not have to spend it all. So this is an inequality. Sodas cost $1, chips cost 75 cents. What are some ways that I can spend the money? Of course, we could work through every possible combination, but by graphing it, we can quickly see all the possibilities. Today, we will graph inequalities so that we can quickly see all of the options. Yeah, I can make a table. I could go like 1 soda, 1 chip, 2 sodas, 1 chip, 3 sodas, 3 chips, and sort it out. But a graph will be faster for us. So this is a review of graphing. You do not have to put this into your notes. I know that this is the y-intercept and this is the slope. So I'm going to start at 1. I'm going to go up 2 over 3. And there's the graph of it. Slope-intercept equation, Liam the leprechaun, rise over run, all stuff that hopefully you've already mastered. Now, when I graph an inequality on a number line, I have to think about the type of circle and which way I would shade. So here, it's an open circle at 3. And I want to shade the numbers that are greater than it. All right, so this one we're going to graph in our notes. So graphing linear inequalities, let's start with our name. And on the previous slide, we talked about circle types, open versus closed. When we're graphing lines, we have to have an open line or a closed line. In order to show that, we use solid or dashed. So let's go with this. A less than or a greater than. A less than or equal, a greater than or equal. What type of circle would these be? These are open circles. And these would be closed circles. But we're not going to be graphing on a number line. We're going to be graphing on a coordinate system. So we need another type of way to show it. So this would be a dashed line. And this would be a solid. A dashed line is not part of the solution. So a number that's on a dashed line does not work. A number that's on a solid line does work. So when I look at this guy right here, is it going to be solid or dashed? It's going to be a dashed line. So we're going to graph this in our notes. So let's graph and we know it's a dashed line because of the inequality symbol. Graph paper would be better for this, but I know you guys are just using notebooks, so let's make it work with this. I'm still trying to use the lines of my paper pretty nicely. So where would this start? It would start at 1, so it's going to start right about there. I'm using the lines as 1, 2, 3. Then it's going to go up to 1, 2, and over 1, 2, 3. You told me it was a dashed line. Now we have to determine where to shade. Do I shade above the line or below the line? We want to shade the true area. I'm going to test 0, 0. If 0, 0 is true, that means I'll shade underneath it. If 0, 0 is false, that means the other side must be the true area. So let's test 0, 0. Zero is less than 0 plus 1. I took that 0, 0, and I plugged it in up here. 0 is less than 0 plus 1. 0 is less than 1. That is true. So if this point is true, that means everything underneath is true. So I shade underneath the line. Everything over here is true. And that's how you do a linear inequality. The shaded area represents all the possible solutions, everything underneath. The line itself is not a solution. So a point on the line, such as 3, 3, is not part of the solution. 3, 3 does not work. Everything above doesn't work. Everything on the line doesn't work. Everything below does work. Excellent, we did that. All right, this one does not have to go into your notes, but I'll do it with you. Choose the line type. So looking at this guy, solid or dashed? Dashed. Solid or dashed? Solid. Solid or dashed? Solid. Solid or dashed? Dashed. And dashed. And I see that just by looking at the inequality symbols. All right, this guy. What type of inequality symbol goes with this? Well, it's one of these, right? Because these are the ones that are dashed. And these are the guys that are solid. Same one, or same type. So what do you think? It's these guys over here, right? These are the ones that would make this type of line. So how do I graph an inequality? I think about the line type. I graph the line pretending it's an equation, and then I test 0, 0, and shade the true area. We're going to do this as a thinking map. Thinking map, thinking map, thinking map. Graphing linear inequalities. First thing, think about the line type. So that means solid or dashed. Figure out if it's going to be solid or dashed. Second, we're going to graph that line as if it were an equation. And I have to go to a smaller pen. Graph the line as if it were an equation. So don't even think about the greater than or less than or greater than or equal to. Just pretend like it's an equation. Then, after it's graphed, we're going to test 0, 0 and shade the true area. All right, so let's do some of these. Let's do this one right here. Okay, step 1, solid or dashed? It's solid, got it. Now I'm going to graph it as if it were an equation. So I'm going to start at 3, and I'm going to go up to over 1. And I'll draw a line, and we already said it was solid. Good, solid line. And now I have to figure out where to shade. So I have to test 0, 0 and see if 0, 0 is true or false. All right, 0, 0, true or false. 0 is less than or equal to 0 plus 3. 0 is less than or equal to 3. This is true. So this point right here is true, which means everything underneath it is true. Let's do this one. Solid or dashed? Well, this is going to be a dashed line. I'm going to start at -1. I'm going to go down 2 over 3. And from here, I'm going to draw a dashed line. I am not sure if it's going to let me do a dashed line. I don't think it is. So what I'm going to do, I'll make it dashed though. Don't worry about it. Here we go. I'm going to dash it up. Here I go dashing it. That is some big dashes. Okay, it's a dashed line. Why am I using my mouse? Okay, it's a dashed line. Cool. Now we have to test 0, 0. So let's test 0, 0 and see if it's true or false. 0, 0, okay. 0 is less than 0 minus 1. 0 is less than -1. This is false. This point is false, which means I need to shade on the other side of it, which means this is the true area. Okay, we got this. Let's graph this line, solid or dashed, solid, at x equals 3. So it's a vertical line going through x equals 3. And now let's test 0, 0. 0 is greater than or equal to 3. Excuse me, 3. Is that true or false? 0 is greater than 3. This is false. So this point is false, which means everything over here is the true area. Ooh, all right. Solid or dashed? It's dashed, right? And this is really y equals 1 over 1x plus 0. Okay, start right here. Up 1 over 1, up 1 over 1. Here we go. There's my line. And it's dashed. Now, normally I would try 0, 0, but 0, 0's on the line. That's no good. My next favorite point is 1, 1, but that's no good. Let's try 2, comma 1. And let's see if 2, comma 1 is true or false. Okay, y is 1, and that's greater than x, which is 2. Is that true or false? 1 is greater than 2. That means this point is false, which means everything above the line is true. All this is true. All right, here's one in standard form. So I'm going to do mini equations. So I'll go 3x equals 12, so x equals 4. 4y equals 12, so y equals 3. Dashed line, x equals 4, y equals 3. Dashed line between it. Let's test 0, 0 and see if it's true or false. 0 plus 0 is less than 12. 0 is less than 12. That's true, which means everything under the line is also true. Everything over here, that's the solution area. Excellent. Hey, thanks for watching, and I will see you in class.